Good morning, students. This lecture is for textile technology, textile chemistry, and textile engineering students for the subject textile testing part 2. And we'll study about the bursting strength measurement of fabrics in this lecture. So, first we need to understand why we measure bursting strength. And already we have studied about tensile strength and tearing strength, but still, why we measured bursting strength. Now, for some applications such as parachutes, filters, sacks, and nets, the fabric material is stressed in all the directions during service. So we need to design a test of strength which gives a multi-directional stress. Tensile test is unidirectional and we measure it in the direction of warp or weft. So we go for bursting strength in case of these applications, that is parachute, filters, sacks, and nets. One more point we need to understand is for knitted and non-woven fabrics where there is no specific direction of fibers or yarns, we go for this multi-directional strength testing, which is bursting strength is preferred in case of knitted or non-woven fabrics. Okay. Now, one thing we need to understand in case of bursting strength, which is the most important point, is when the stress is multi-directional, fabric fails across the direction which has lowest breaking extension. This is the most important point. If the fabric is made up of different types of warp or weft, and both yarns have different properties, different tensile properties, the yarn which is having lower breaking extension, fabric will fail in that direction only while testing the bursting strength. Now, the next point is how do we measure bursting strength? Measurement of bursting strength is we can classify the instrument in two types. One is we can measure the bursting strength on a universal tensile tester with the help of a steel ball. The line diagram is shown below. And the second one is diaphragm bursting test. So first we'll discuss a diaphragm bursting test. This is the line diagram. In this we can see there is a rubber diaphragm, circular, and then a circular red specimen which is shown in side view here, and the annular ring clamps are there to clamp the fabric on the diaphragm, and the liquid beneath the diaphragm is there, and we increase the pressure of the liquid up to that point at which fabric bursts, and the results are reported in units of pressure. This is very important in case of bursting strength. The results are reported in units of pressure. So first in this case we have to take two readings, one blank reading, that is without fabric, and one with fabric reading, and then we have to take the difference of the pressure in both the cases and report it as bursting strength. So this is diaphragm bursting strength tester. The other option is if we can go for ball bursting strength. The line diagram is shown here. This way. So there is some sort of attachment is there on the jaws of the this tensile tester, and we just press a 25 mm steel ball through the fabric and we note the force required to burst the fabric. So in this case the advantage is that this test can be done on tensile tester only, and we just have to need one attachment, and but generally that diaphragm bursting strength is measured, and that instrument is more popular, which we have discussed earlier. This one. So one more factor we can note from here, that crimp percentage of the warp and weft direction is also important. The direction with lower crimp will have less extension and will have lower bursting strength. So crimp is also an important factor which contributes to the bursting strength of the material. So here I complete this small topic of bursting strength measurement of fabrics. We will meet in next class. Thank you.